We can have the dialogue between Dr. Michaels and Greg Diamond, Esquire.
I am the General Counsel of Cato, the Coalition of Anaheim Taxpayers for Economic Responsibility, which is sponsoring this event. Before I was a lawyer, I was a scientist. My dissertation at the University of Michigan in 1990 was actually on how individuals respond to the kinds of collective threats that we're looking at today. Then taught actually in political science at the University of Illinois for 4 years, and then went elsewhere as well. So if you're thinking, what is that lawyer doing up here? I also do have a background that's somewhat relevant to this stuff. I'm going to be talking to Pat informally about some of the various issues that that come up in relation to this. And this is something, Pat, have you had this happen in previous presentations you've done?
I think I talk too much in about every venue that
Okay.
I'm in.
Okay, so we're going to try to do something informal, which will be a little bit different from what you've seen there, which you might see at a conference or something like that. The first question I would like to ask you, do you believe that I and Mark and John are sincere in our beliefs that climate change is anthropomorphic, not anthropomorphically, anthropogenic, and that it's also something that humanity can perhaps change?
Well, you're sincere, and you're certainly right that climate change is real. The operative word in your question was the word can change. Now, the EPA's model that I showed is not challenged. It's been around for about 20 years. Just ask yourself, if the word change means that we reduce global warming by 0.14 of a degree C, if we have no emissions of carbon dioxide whatsoever from the United States from now until the year 2100, I guess that's right. But seeing as we couldn't measure 0.14 of a degree C because the temperature naturally oscillates about plus or minus 0.07 or 0.08 degrees C from year to year, so you'd never be able to measure that change. Now, I would say further in response, it's quite possible, in fact, it's probable, it's likely, that everybody in this room, and I really don't mean to insult the audience because I'm talking about myself too, doesn't have a clue what we're talking about. And if I could, I'd like to take you back to the year 1915. And a group of people had formed a club of concern because they had read the paper by the great Servite Arrhenius in 1896 in the journal Philosophical Transactions, in which he calculated that if we doubled atmospheric carbon dioxide, the surface temperature would rise 4.5 degrees Celsius, and if we raised it by 50%, it would rise 3 degrees C. And so these people were concerned, and they consulted a seer. They consulted a visionary, a known oracle. And they said, "Oh, great oracle, what will happen to energy in the next 100 years? We're very worried about this." And the oracle said, "It's 1915. In about 20 years, you're going to realize that the last element in the periodic table is not uranium, because you're going to make an element by splitting atoms. And then, if you took a ball of that and held it in a confined space about the size of my hand, it would blow up the city of Washington, D.C. That's just going to happen in a little after 20 years. But if we divided it into fine columns and immersed them in water, it would power the city of Washington for 100 years, electricity being something new. People said to the seer, "You're insane." And then he said that about 40 years after that, you would fly through the air at 600 miles an hour, and there would be a box in your pocket that could access all the information in the world. That time they stopped listening to the seer. The seer had one more thing to say. He said, you know, we have multiple streams of energy, and people are going to say we're running out, it's the end of the world, for a substance called natural gas. Very, very useful source of energy, it turns out, in the late 20th century. And then all of a sudden, they are going to discover that there are hundreds of years of it beneath their feet, and all they have to do is break rocks. You know what they told the seer? Get out of here. You're crazy. That's what happens in 100 years.
Okay. So you do think that we're sincere?
I believe.
Okay.
Absolutely. You're as sincere as I am.
Okay.
Take that for what it's worth.
And I believe that you are sincere as well. Since you brought up a number of things, I'm going to depart from
the script.
The order in which I was going to ask you questions. And by the way, I just wanted to say, just as a scientist, the presentation that you gave about the diminution of the fat tail, which is essentially the low probability that something really extreme is going to happen, is really the sort of thing that I'm looking for in trying to analyze these issues. It suggests that when that probability of over a 10% likelihood was that it could be substantial change, that people were probably legitimate in being concerned about it. I presume that you'd agree.
Well, I would agree, except I think it was also evident to people of some critical thought that the warming in those models was known to be too high at the time they were published.
Well, I'm just thinking about the theory of science part of it. If you have that sort of a high probability of something 10%, that could be, if you give credence to the model, then you might say, yeah, 10% is not that big.
Here's what he's saying.
But
let me translate this, could I?
No.
Yeah.
Okay.
What you're saying is, really what you're for is an insurance policy. That's really what you're thinking. And you know what? I think insurance is a wonderful invention. But the only problem is the price of the insurance policy for the house that you're trying to insure is equal to the value of the house. And that's the problem. We don't know. It's not insurance. It's too expensive.
Okay. Well, that's something I just want to get the model out there at this point. Let me get to some, but anyway, that's the idea, to try to make this clear to the audience, of how likely is a really extreme result. And if you have the fat tail under distribution, even though it's much less than what you've seen before, that means it's likely. If you have a thin tail, which is what he said has happened in the past few years, then it's something that perhaps you might feel better about ignoring, or at least not making too big of a deal of. Am I basically correct there?
Well, Ken, you're a scientist and you understand that words have meaning. So we have to be precise.
I'm also a lawyer, and I understand that words don't always have meaning.
Well, that depends on what the meaning of the word is.
Okay.
So what I'm saying, you're saying that there's a certain level at which you ignore the issue. And I'm saying no. You don't ignore the issue ever, because energy systems will develop and evolve. And I can't tell you what's going to happen, but there's incredible pressure on companies that are competing with each other to produce things that are more efficient than their competitors, or to produce things more efficiently. Okay. So you never ignore the issue. You really
I'll give you an example of an issue that we might ignore on just this basis. There are concerns, for example, that at some point an asteroid, a planetoid, or something like this might smash into the Earth and end life as we know it, just as apparently did happen to the dinosaurs with the meteor that fell in the Yucatan. The probability of that is pretty low. I think we can agree. And people yet in Congress have been talking about spending billions and billions of dollars in order to create, exploratory systems where we can look out in all directions and see whether there appears to be something coming at us and growing brighter. If you believe that the chance of that is 1 in a billion, you're probably, in effect, going to ignore it. If you believe that it's 1 in 100,000, 10,000, then you're not going to. That's all I'm trying to make. with that observation.
I think that's a reasonable surmise. But don't you think it's kind of amazing that people can go around Washington knowing, people who know astronomy, who know history, knowing how many big strikes there have been on the Earth? The answer is very few. And saying, let's euchre $100 billion out of these people over the course of 10 years. So
I was just trying to throw you off track.
What I'm saying is it's the power of the hot medium of 24-hour news. That's the only thing that could have people actually serious about spending that amount of money on an asteroid strike. Mm-hmm. Good God.
And yet,
there
were hearings about it. Okay, let me get to some of the specifics of the data that you presented. What we've been talking about today almost exclusively, at least I didn't notice any exception to it, was about the amount of atmospheric carbon dioxide that we have. And yet that's not the only potential greenhouse gas. And especially when we talk about the rise of the internal combustion engine having an effect on things, yes, that would be CO2. But I know that there are other gases as well. I think, isn't sulfur dioxide one of them?
No, sulfate's cool. Well,
okay,
you think about methane.
Methane, yeah, is the primary one, but I believe there are others as well.
Methane's a really odd one. Methane is a very potent greenhouse gas. A molecule of methane absorbs 14 times, or 20, depending on who you talk to, more infrared radiation than a molecule of CO2. And it's going up. It was going up in the atmosphere, and it was going up at a constant rate. And so everybody assumed, when we first started looking at this, about the mid-1980s, that, yeah, it was going to continue to go up. And as soon as they assumed that, all of a sudden it started to tail off, and it actually started to go negative in the atmosphere for a couple of years. Do you know why that happened?
No.
Nor do I.
Okay.
I don't know. Do you know why it started back up again? I don't know. So nobody knows where that's from.
Okay. I might guess statistically there might be some regression to the mean going on there, but who knows?
It's just weird, okay? When scientists say they know something, when scientists say they know something for certain, I always get very chary. Now, yeah, we know the Earth is round, okay? That we do. But do we know how much CO2 is going to be in the air in the year 2100? Do we know how much methane? I don't think so.
Okay. Well, actually, I know there is some news, and I've been told by people that I'm stepping into a trap by bringing this up, but I'm going to do it anyway. There has been news recently about, as you've had increasing temperatures in the northern regions, on the tundra in particular, that you do now have greater emissions of methane that are bubbling up from under Siberia.
That's a trap. You were advised very well, okay, because you do not see any uptick in atmospheric methane. And that's even better. Who was the fine gentleman who spoke before? Mr. Hoaglung?
Just before you, yes.
Yeah. He showed something very, very interesting in his first graph. I don't know if you caught it. There was a little thing on the left-hand side that said PETM. That's something called the Paleocene-Eocene thermal maximum. And what happened, and don't ask me why, I've heard a bajillion explanations for this. The Earth just exploded in volcanism. And the amount of CO2 that went in the air was about 30 times as much as we could put in the air, even if we tried. So if there was going to be a runaway greenhouse effect, if every volatile infrared absorbing compound was going to be released from the Earth's crust, it would have happened then. But it didn't. And so there are limits to warming.
Well, that assumes that what's under the crust is always going to be constant, right?
I
actually don't know. John is who I'd ask.
I wish he's gone, isn't he?
Oh, I hope not.
You're here. Okay, so tell me about the PETM. Well, I mean, it was like about 30 times what we could put in, right, in terms of the total amount.
Well, I've heard everything from ocean overturns to volcanism being caused. So
yeah, it's
an unknown, and I'm not a paleontologist from the Eocene, so I'm not going to.
I thought you were from the Eocene.
Yeah.
You look like you're from the Eocene.
It's the hair, but it's stylish, actually.
But the point that I wanted to make about the Eocene is this.
Can you go up to the microphone, please?
No, we forget the chair in the middle.
Yeah, do you